Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Hello everyone, welcome to Physics Blender e-learning platform. Today we are checking your answer, your homework. You have refraction of light, paper 1 for core and extended. Okay, let's start question number 1. Okay, question number 1. The diagram showing a ray of light passing from glass to air, from denser to less dense medium. And again, one more time, when we are talking about optically denser, okay, it doesn't mean the actual density we discussed in topic 1. Okay, so optically denser, it means its ability or it has greater refraction effect. It has greater refraction effect. For extended students, optically denser means its refractive index more. Its refractive index is greater. Okay, so which angles are the angle of incidence and the angle of refraction? The angle of incidence is the angle between the normal, the dotted line here, the construction line, and the incident light ray. So which angle here? X is the angle of incidence. The refracted ray here is refracted at the boundary. So the refracted ray here at the boundary, so the angle of refraction is Z. So you have Z and X, so you have to choose D. Okay, about values, for this case the angle of refraction is 90. In critical case, the angle of refraction is 90 degrees in the less dense medium. Okay, question number 2. Light enters a transparent block. The light is refracted into the block and then strikes the top edge of the block at the critical angle. So in this case, at the critical angle, the correct diagram you have to follow. The arrow, you have to check the angles are correct. You have to follow how the light ray will behave inside the block and when it emerges from the block. Okay, so number 1, since it strikes the top edge of the block at the critical angle, so you have to choose between A and C, because a critical angle is an angle of incidence, so B and D will be excluded. Okay, so in this case you have to check R, the angle of refraction. It's the angle between normal and the refracted ray. So R here is correct, R here is not correct. And C, the critical angle, the ray will emerge at the boundary, and C is the critical angle, which is the angle of incidence in this case. Is it clear? So the answer is C. That's why we are choosing C. Okay, question number 3. We have here a scientist is trying to direct a ray of light through a glass block without any ray leaving the top of the block. So it means the scientist is trying to allow all the rays to be totally internal, reflected inside the glass block. So in this case, what are the changes to angle x. So we are increasing angle x. The light in this case is away from the normal, almost close to the boundary. So we have here the boundary. So the ray almost close to the boundary. So if we increase angle x to be more than the critical angle, so the light rays all will be totally internal reflected inside the glass block. So you can change angle x to be increased, and the effect which will produced here is total internal reflection. Okay. Question 4. The diagram showing a light ray traveling from substance P, it's a medium, we have no idea about this substance, and it reaches a boundary with substance Q, total internal reflection takes place. What about angle X and what about substance Q? Okay, you know, in this case, it's total internal reflection. Guys, I'm trying to use this abbreviation, but I think in your exams you have to write down a full complete sentence in words. Which row contains correct statement? And what about the optical density of substance Q? Okay, so the light ray here from denser. Actually, let's revise the 2 requirements for total internal reflection. We have 2 requirements. Number 1, light ray passes from denser to less dense medium. So these are the 2 requirements for total internal reflection. The second requirement, that angle of incidence should be greater than the critical angle. Okay, so number 1, angle X should be greater than the critical angle, and which one, it takes place inside the denser medium. So substance P is denser, and substance Q is less dense than P. Okay, so here is the denser and here less dense. So substance Q should be less dense than substance P, and the X should be greater than the critical angle. Is it clear? Okay, question 5. What happens during refraction when light waves trying to pass from air to glass and they are refracted? There is change in direction, bending. Which feature or what will be constant here? What always remains constant? The frequency. Frequency remains constant. The wavelength changes according to the medium, speed changes according to the medium, and also the direction changes. Okay. Question 6. A ray of light in water here is incident on the surface. The angle of incidence is much smaller than the critical. Since angle of incidence is smaller than critical angle, so normal refraction takes place. So what happens here? The ray will be completely reflected. No total internal reflection. Completely refracted, I will try to tell you now what happens. It's refracted at an angle of refraction 90, which means at the boundary. No, because angle of incidence is less than the critical angle, not equal to, is less than. So here refraction, normal refraction takes place. But here the correct answer is C, partially reflected and partially refracted. Why? Because in another question I told you, if we have here normal, we said that it will refract away from the normal. So this will be the refracted ray. Okay, most of the rays will be refracted, but we have here weak, it's called weak reflected light ray. So we have here, this is called weak reflected ray. Okay, so most of the rays will be refracted and weak reflected ray. So the answer is partially reflected and partially refracted.
Subscribe for more videos. I love physics splendor. I love physics splendor. I love physics splendor.